So today I want to talk about functions. They are a thing that bedevils a lot of people, and the way they're taught often confuses people. I didn't truly understand functions until maybe I was in college and I was taking a chemistry course or an economics course that actually used a function, and I thought, oh, I understand that now. I wish someone could have told me this in ninth grade or eighth grade when we started working with them. So conceptually, I like to think of functions as a machine that takes an input and does something to it. So something might be multiplying it by 3. So you put a number into the machine. Here's your little box. Call it F for function. So you get a 3, put a 3 in, you get a 9 out. You have a separate function, a G function. It could be that it divides your function by 3 and then adds 1. So if you put a 3 into that, 3 divided by 3 would be 1, and then plus 1 would be 2. If we put a different number in, like, I don't know, 12 into G, divided by 3 would be 4, add 1, it gives you 5. So this input is called the domain. What could you put into a function? So a difficulty with domain and range is the output. We'll go over that soon, but in general, both domain and range, a difficulty is that when we're talking about something simple like multiply by 3, or I'll write this right up here, times 3 is what this does, divide by 3 plus 1 is what G does. So when we're talking about multiplying by 3, you can multiply any number by 3, right? So it seems weird to say, what could I multiply by 3? And in fact, that's most math functions that you deal with, especially early on in like Algebra I, Algebra II. When you get into more complicated functions, sometimes it doesn't make as much sense to put a number in there. So for example, so the function, let's do h the function, we'll call it h of x, this is what they normally look like, equals 5 over x. That's not actually that complicated, but there's an important exclusion from the domain. You are not allowed to divide by 0. So the domain of this function is any number you want except not 0. If you had j of x, we've seen a j function before. Wonder why that is. Maybe it's because vectors are j's. If you had another function like square root of x, again, not super complicated, but you can only put 0 and positive numbers in that j function. So that's another example of this domain is limited. If you think of real world functions, like for example, here's maybe a graph of how tall you were at certain ages. And this is you shrinking later on, so this is time, and this is height. Okay, well, what if I ask you, well, how tall were you when you were -1 years old? Well, you were never -1 years old. So it only makes sense, and say this is when you die at a ripe old age of 115, just like I'm going to. If you ask how tall am I when I was 121, the answer would be, I don't know. I didn't have a height when I was 121 years old because I was dead. Because you could talk about my corpse, but usually we don't talk about how tall someone is when they're dead. So there's only a limited set of ages that I could ask this function for and have it give a meaningful answer. So the inputs for this, if someone is between 0, or someone lives to 115, is between 0 and 115. And then the range is what does it ever spit out. So I would love it. I'm about 5'9", so let's do this in inches. That's nice. That's the tallest I'm ever going to get, unfortunately. I'm never going to be 72 inches tall. So if you ask, well, what age was Joe when he was 72 inches tall? somewhere up here. The answer is, well, there's no age. I can't give you an age for which I was 72 inches tall. So that's outside of the range of this particular function. Same thing with, if you said, what about when I was 5 inches tall? Unless you want to count a fetus, if we're talking about when I'm a fully formed, independent of my mother human, I was probably around 20 inches when I was born. It's the shortest I'll ever be. So if you said, when was I 5 inches tall? The answer was, well, never. That's outside of the range. So the range of the function is the answers that you could possibly get out of the function. So let's go to a new page. Again, if you think about a function as sort of a machine that takes an input, gives an output, there's all sorts of things. The example I like to give is a literal machine. Let's see if I can draw a picture here. I'm pretty good at drawing numbers and shapes. That's a pretty good vacuum cleaner. So why are the wheels down there? It's not going to be able to get any suction. Anyways, so a vacuum cleaner. Its domain, what does it work on? What does it make sense to apply the vacuum cleaner to? Well, you wouldn't apply it to the outside of a car, right? That would break something potentially. You wouldn't apply it to probably a hardwood floor. You'd apply it to a rug. So the domain of the vacuum cleaner is rugs. And then the range, it's a machine, right? It's going to spit out either a dirty rug or a clean rug. If it's a dirty rug, then it's probably a broken vacuum cleaner. The rug is dirtier than you thought, but some sort of rug, again, but maybe a different type of rug with like a little bit less dirt in it. So it's never going to spit out a hardwood floor. It's never going to spit out a car. It's never going to spit out a loaf of bread, right? It's going to give you a clean rug. So that's a more literal version. So again, when we're talking about functions, the question is, what could it possibly spit out? A good example of this, a little more complicated, and this is where, again, maybe this would be an opportunity for it to actually start to matter, would be the sine function. So the sine function takes an angle in and it answers the question, so say sine of 45 degrees. What is the ratio between this side opposite the 45 degree angle and then this kind of hypotenuse type thing here? Okay, and what is the ratio between it? So it takes an angle in it. It says, hey, I have a 45 degree angle. Can you tell me something based on the fact that I have a 45 degree angle? And then specifically, that is root 2 over 2, which is like, let's see, I think it's like 0.707. So it's a number. It spits out a number. There's a different function, the sine inverse, that takes a ratio. I'll tell you what a sine was. I'll tell you that a sine was maybe, let's say, 0.707. And I'm asking you the question, what is the angle that gave me that? And the answer here, 45 degrees. Okay, so this takes a fundamentally different thing in from what it spits out, and you could have the reverse function and it takes the other thing in. So it takes a number like a ratio like 0.707 and it spits out an angle. That's the sine inverse function, and the regular sine function takes in an angle and spits out a ratio, a number. So those are two fundamentally different things from each other. So that's where you'd want to talk about, domains and ranges more carefully, and they're a more meaningful thing. So hopefully this was helpful. Again, the sooner you start thinking about functions like this, the more sense all your questions on your homework is going to make. Because honestly, I was kind of doing it by rote, and this is one of the things I didn't quite understand as I was doing it during my first couple of years of algebra. I think trig helped a little bit, but even there I got myself a little bit confused. If you always think of functions in terms of inputs and outputs, they start to make a lot more sense.